Okay, this is our last video on solving quadratics, and we're going to wrap up this unit by discussing the quadratic formula and the discriminant. Now, these are two very important vocabulary terms that you need along with the formula for each of them, so please make sure that you have this written in your notes with your vocabulary. The quadratic formula looks extremely complicated, but it is very simple when you break it down. We have dealt with this same trinomial for weeks now, all the way back into multiplying and factoring trinomials. So ax squared plus bx plus c is not anything new. Equals 0 makes this the equation. We're looking for the zeros of the function. We're looking for what is x going to be when y is 0, those x-intercepts. Now, if you can identify the a, the b, and the c in any quadratic equation, then using the quadratic formula is going to be very simple. You just take every one of those values and plug it into this formula. So please make sure you have this formula written correctly and well so that you can read it in your notes. The formula for the quadratic formula is x equals the opposite of b. So just like it was, we've talked about opposite of b plus or minus. Now keep in mind that when you take the square root of something, you're going to get a positive or a negative solution. So we're going to have to deal with both of those. We're going to have to deal with the positive solution and the negative solution. So that's why we have the plus and the minus there. So the opposite of b plus or minus the square root of, and you have to make sure you take the square root of this quantity, b squared minus 4ac. All of that is divided by 2a. So be sure that you're not just dividing the square root part by 2a, you're dividing that entire numerator, the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so this is the quadratic formula. Be sure you have that. And there's an example here, but we're going to look at one in just a minute. The other thing I want you to look at, we're going to need for the last example we do, is the discriminant. And the discriminant is going to tell us the number of solutions of the equation. Okay? Using your quadratic equation, ax squared plus bx plus c equals 0, if you look at just the radicand, that's the number under the radical sign. So b squared minus 4ac is the expression under the radical sign in your quadratic formula. If you just use that little bit, plug in your b, your a, and your c, the value that you get is going to determine the number of solutions. Okay, and we're going to get into more of what that looks like as far as the discriminant, but this right here, the part that's under the radical sign, is going to determine the number of solutions your equation will have. Now remember, we talked about this when we talked about x-intercepts. It may have two real solutions. That means it crosses the x-axis twice. It might have one real solution, which means it just sits on the x-axis. Or it might not have any real solutions at all because it is above or below and never crossing the x-axis. So that could happen. We could have those different variations here with the quadratic formula and discriminant. So let's look at this first example. We want to find the solutions to this quadratic equation using the quadratic formula.
First, write the original equation. Then write the equation in standard form. Why do you need to write the equation in standard form?
This is very important, and this could be the difference in you getting this answer right and wrong. If you do not write this in standard form, you're going to use the wrong values for A, B, and C. So anytime your quadratic equation does not say equals 0, you need to make it say equals 0. So you need to move whatever term you have here over. And notice that they did the little switch here with the negative 2x and the negative 8 because they needed it in the correct standard form.
You can only use the quadratic formula with equations in the form a times x squared plus b times x plus c equals 0. Now use the quadratic formula.
All right, think about what's your A, what's the number in front of your x squared, what's your B, the number in front of the x, and what's your C, and they've got this color coded here. Your A's are red, your B's are blue, and the one time you use C right here is green. And substitute those values into this formula. Substitute first before you ever start typing this in your calculator.
Substitute 1 for A, -2 for B, and -8 for C.
Now notice, it's the opposite of B, and B was -2. So that puts two negative signs side by side. But all they did, and this is extremely important, and I've stressed this several times, you take the number and plug it in using parentheses. You can do all the simplifying after you've done the initial substitution. So take the numbers and plug them in using parentheses in the appropriate places.
Begin simplifying this equation.
Okay, all they did was two negatives side by side. This becomes a +2. And they squared -2. They multiplied 4, 1, and -8. And then they took care of the addition there. Negative times a negative here gives you a positive. So they just took care of the simplifying. You could do that in your calculator if necessary. Now you need to continue to simplify this to get the actual x values.
Now write this equation as two separate equations.
We did this in the last video. You have a plus and you have a minus. You have a positive and you have a negative, which indicates two different equations. So separate it into those two different equations. That way you can solve for x in both scenarios.
And simplify each equation. The solutions are x equals 4 and x equals -2.
So extremely simple. If you can substitute in values and use your calculator to solve the quadratic formula after you've plugged those values in, you can do this. This is very easy. So now it's your turn.
Now it's your turn.
I want you to use the quadratic formula to find the solutions to this quadratic equation. Now, first of all, remember, it has to be in standard form, which means it has to be in ax squared plus bx plus c form equals 0. So make sure you change that first and then use your quadratic formula to plug in a, b, and c and solve. Now, this is going to take a minute, so if you need more time, pause the video. But hopefully you're coming back from answering this. Your correct answer is -3,7. I'm just going to put that up there. That your B was -4, your C was -21 because you had to move it over, and your A was simply 1. And then you just simplify from there. All right, we're going to look at an example of discriminant real quick.
In this problem, you will use the discriminant to determine the number of real number solutions of a quadratic equation. How many real number solutions does the equation 2 times x squared minus 3 times x equals -5 have?
I don't want to know what the solutions are. I want to know how many solutions am I going to have. That's what the discriminant will tell us.
Start with the original equation. Then write the equation in standard form.
These are very good notes to have, so make sure you're copying this down so that you know how to find the discriminant.
Add 5 to each side so the right side is 0. Evaluate the discriminant by substituting 2 for A, -3 for B, and 5 for C. Can you solve this problem another way?
Think about another way that you could figure this out.
Yes, you could actually solve the equation to find any solutions. However, you only need to know the number of solutions, so use a discriminant.
This is what I was just talking about. It's not asking us for the actual solutions. It just wants to know how many or the number of solutions you should have.
Find the discriminant, b squared minus 4 times a times c.
So -3 is B, so plug that in for B. 2 is A. 5 is C. So just substitute using parentheses your values.
Now simplify. The discriminant is -31.
Okay, -3 squared, 4 times 2 times 5, and then you just subtract.
Use the discriminant to draw a conclusion about the number of solutions. Because the discriminant is negative, the equation has no real number solutions.
When your discriminant is negative, that means you would have to take the square root of a negative number, because remember, b squared minus 4ac is the expression under the radical sign, and it's not possible. You cannot take the square root of a negative number and get a real number solution. So if your discriminant is negative, which is -31, if it winds up negative, then you're not going to have any real solutions. So you need to jot this down. If your discriminant is negative, you will have no real number solutions, because you can't take the square root of a negative number. If your discriminant is positive, then you will have 2 real number solutions. You can take the square root of any positive number. It may wind up being a decimal, but that's okay. You can take the square root of any positive number and you will get 2 real number solutions. And then if your discriminant is 0, after you take b squared minus 4ac, if the discriminant is exactly 0, then your equation will have 1 solution. So a negative discriminant has no real number solutions. A positive discriminant, you will have 2 real number solutions. And if the discriminant is 0, you will have 1 real number solution. So use that information.
Now it's your turn.
On this problem. Make sure that you write this in standard form first, then use the discriminant, the piece that's under the radical sign, to determine the number of solutions you should have. All right, pause the video if you need more time, which you should probably, to make sure this is in standard form and you substitute correctly. But your real number solutions, you should have 2. When you take the discriminant, b squared minus 4ac, and you plug in the 6, the -5, and the -7, you get 193. 193 is a positive number. There are not 193 solutions. That is just the discriminant. That is the number under the radical sign. And because it's positive, I can take the square root of it. That means I'm going to get 2 real number solutions out of that quadratic equation. Make sure you have the quadratic formula, the discriminant formula, and all the information that goes along with each of those before you return to class, so we can look at some more examples and more in depth.